All right, so Going Native 1 and Diego and I mean, what's going on? We're cool. That's what's going on, right?
The first program was really a total success. Program 0, actually.
Program 0, man. That's always start at 0. This is 1. So we've iterated 1 time.
Sure.
So congratulations, man.
Oh,
I really enjoyed it, but we have a lot of work to do. Incredible amounts of feedback have come in. Thank you all.
Very constructive.
Most of it positive. You know, I mean, I've taken a few hits on Channel 9 recently, but that's okay.
Yes, yes. We were doing everything, you know, so it's like we are taking care about that. Constructive feedback we also got.
Constructive feedback, rock and roll. So some of the feedback that we get is, and I know I've gotten this from developers all the time, are not really necessarily about our compiler.
Okay.
Or, you know, the linker. I mean, come on. Or, you know, STL, blah, blah, blah. But rather, the container in which we compose code.
Okay, okay.
The IDE.
The IDE, okay.
So I wanted to ask you right off the bat, we want to jump right into this in the constructor.
Well, thank you for introducing the topic, because so far, you know, until Visual Studio 2010, it was noticeable that the developer experience when you were coding C++ applications or C# or VB applications was different. In particular, several developers are telling me that they are doing C# and C++ as well. And they ask me, why can't we get, you know, the same developer experience in one case than in another?
Yeah.
So I have certain good news to show you.
Good.
Because, I mean, and when I say show you, I'm going to do some demos.
Great.
And we will see a first look about the next version of the Visual C++ IDE.
Awesome. Well, you know what? We could sit here and talk and ramble and do whatever, but let's not. Let's check those out.
Absolutely. All right, so what we have here are 2 versions of Visual Studio. On the left we can see the current version, Visual Studio 2010, and on the right we can see a work in progress version of Visual Studio vNext. I can't guarantee that the look and feel will be exactly like this, but these are the prototypes we are working today. So the first thing I want to notice or show you guys is, you know, the Solution Explorer. We can find that now we have, you know, here like search bar. So I can start putting, for instance, something like this. And it starts looking onto my project, you know, and it can find, you know, for instance, all the instances that are being used by this. So don't worry about the performance on this version. This is just a work in progress. It may slow a little bit, but I can show you a glimpse about what are the functionalities that you may find in some features. So you can find, for instance, in this case, what are the source files that are making reference to the type I just entered. So something else I want you guys to notice is that while both trees look similar, they are actually the same project open at the same time in both editions. We can see that in vNext we have now the chance, you know, we have certain options. I can expand every source file or even every header file, and I can find there all the symbols that are defined and all the classes that are defined as well, you know. So for instance, in this case, I can keep expanding. I can find, you know, all the methods, constructors, destructors, etc. And for sure, it may happen that if I double click, for instance, I can get access, you know, to the version or the you know, the definition, declaration I'm doing. So let's switch back to this view. Something that I'd like to show you and compare. If we just close these 2 things, I have here open, you know, the same source file. And while they may look somewhat similar, you can notice that in the next version, the coloring of symbols is somewhat different, you know. It's like, I will expand in this case. Let's see, this is the version we have today. And you can see that despite, you know, some preprocessor directives or some reserved words of the C or C++ language in blue color, the rest is almost black, you know, comments are in green. But when we switch, you know, to the next version, you can notice that we are using more colors in this case for the different aspects of the file. So for sure, trying to understand the code, it tends to be somewhat easier, you know. For instance, you may notice that now arguments on method or functions are in italics. So inside the method, you can immediately notice where we are using, for instance, an argument received, you know, as parameter, or maybe, you know, in this case, like any internal variable or any internal property the class has. So, you know, coloring and the Solution Explorer are the two first aspects I wanted to show you. Something else we can notice here, let me just close this file, let's open this other. It's somewhat simpler, so we'll understand it better. We have here, you know, for instance, certain variables that are being initialized. So if I click on any of these, I can notice when I, you know, go through the file that all the reference to the variable I just click are highlighted. You know, it can happen, for instance, if I click on, you know, in this case, this argument, or, you know, this other, etc. So this is another aspect that helps you, you know, understand files or source code, you know, in an easier way. So this is called reference highlighting. This is the kind of feature we are adding. Something else is the possibility of search. In this case, in the file, if I press Ctrl F, it's like I can find here, you know, I can start typing anything, and it highlights, you know, all the reference that I may find in this file. So it's like I can keep moving on this and immediately traverse all the references to the variable or symbol or anything that I'm, in this case, looking. So this is not just limited, you know, to source code. I can. Has it ever happened to you guys? You needed to change, let's see, the font or something else in the file, and you don't remember in which of the many options the menu has. You know, we were trying to make the menu simpler, you know, but there are so many features that we always need to reorganize, etc. So there is a simpler way to find whatever you want. If, for instance, I want to change the font, you know, I just type font in that quick launch box, and when I click, it's like I immediately can find, you know, in the options where it's particularly the setting I want to change. You know, it would have been the same if I remembered, you know, where to find it, you know, and I just came through. So, you know, font is the other aspect that I wanted to tell you. And something else that we can check here. Let me open, for instance, this, you know, this file. Something else is related with IntelliSense. It's like IntelliSense becomes easier now. So, for instance, let's imagine that you are working, let's say, you know, on any part on this source file. So I start here. Let's see, I have, you know, this class that I know. So IntelliSense is proactive, appears, you know, immediately that I'm writing. So we have here one of the many conventions in, you know, in naming functions. In this case, consists in putting in capital, you know, every word in the name of this method. So I can just start, you know, typing the three first word, the three first letter, you know, and it's filtering. In this case, it's filtering the many options that have this string within. However, if I want to go fast, you know, to, for instance, get max, dumps, count, I can just start typing the initials in this case, you know, and it's like it's immediately filtered for me. So this is another feature we added, you know, to IntelliSense. It's not present today, and will make you, you know, traverse files, you know, and find whatever you want easier than before. So the last feature I wanted to talk here is that we also added, you know, IntelliSense. Let me just delete this. So we added code snippets, you know, to C++, because this was a feature that for many years has been present in, you know, in other languages, but not for native developers. So you can have code snippets, let's say, for some preprocessor directives. You may find code snippet for whatever you want. So for instance, if I click here, I can later shape better what I'm doing in this case. And it's a easier way or more productive of writing code. So these are more or less the features I wanted to show you that we are targeting to include in the next version of Visual Studio.
Dude, that was awesome.
Well, thank you.
Thank you so much for adding code snippets. Just the other day, I was asking myself, what the heck's going on here, man? Why can't I have those as well? So thank you. That's a killer.
So what was the feature you liked more?
Well, the code snippets, man.
Okay.
So, I also like the fact that, IntelliSense looked pretty fast in your demo. I also like the fact that you're searching through your solution space was pretty fast. Very helpful. And I could see when you're dealing with a really large project, you have a lot of class names, you have a lot of type names, blah, blah, blah. I'm going to want to find it quickly. I love that feature as well. What about you?
From the several features I was showing, the coloring is something I really like. That is one of the reasons I try to put at any time, side by side.
Yes.
The old version, I mean the current one actually, and the next one, so you can see the difference and how helpful it is, when you are trying to understand big chunks of code, yourself.
Absolutely. Well, hey, I for one am very excited about the investment you guys are making in the IDE.
Thank you.
Your compiler rocks.
Yeah.
So one of the other things that, in terms of feedback we've been getting, is we want to learn more about the C Runtime Library.
Okay.
Right? And I think that's an excellent point because it's something we take for granted. Right?
Sure.
It does so much work between the compiler and the CRT, right? And the linker. The CRT is sort of in the center of the picture.
Absolutely.
And all of those C libraries are so useful to us.
Well, you know what? I could start talking about that. This is not my main area of expertise.
Okay.
But I really know the expert.
Excellent.
On the standard library.
All right.
Or the CRT, So we could actually visit him, Mahmoud.
So let me ask you a question about Mahmoud.
Yes.
Now, it's my impression that he's essentially the STL, Stephan T. Lavavej, of the CRT.
Absolutely, sort of. He's an engineer as STL, so he can tell everything in that area.
Rock and roll. Let's go find out. You wanted CRT internals, and so they shall come.
Absolutely.
Rock and roll. All right, so draw us a picture of your world.
Well, okay, so my world starts with a compiler. So here is CL, our famous compiler. We also have the linker, link.exe. And here we have the Win32 API, where I call most of the function. And here we have the CRT. So the interaction between the CRT and the compiler is quite extensive. It's actually used in many of the areas. For example, some of the code that the compiler injects into at compilation time into the OBJs or the code that it emits, the object code that it emits, calls into C Runtime functions. Of course, the C Runtime can never call directly into CL. It actually can call functions that the CL can inject into your code. So the CL actually, to be more accurate, it will generate that object code, which will call into CRT functions. For example, the GS cookie we just talked about, what actually happens is the CL will inject code into the OBJ that will make use of internal CRT functions such as GS report or GS support functions that will actually allow you to check the stack. It actually has, we have a function called check ESPP in the CRT that will allow you to check whether there's a stack pointer has been invalidated or not. And then depending on that, it will actually allow you also the same code injected here will allow you to call GS report function. Okay, these are all functions that you can easily find through the source code if you want to. And this one will actually report to the user that it has the buffer. It has a buffer. Your user application has a buffer overrun. So the CRT and the compiler actually are very important. So there's a lot of interaction between these. The CRT also talks to the linker. Well, not directly actually. The linker tells the application how to start your application. The linker links OBJs and libs together. The linker also tells, or actually you tell the linker how you would like to start your application. For example, the linker will actually make sure that what you call in the CRT is the right function. For example, if you don't define any entry point to your application, the linker actually will put in some code, or actually will make sure that the CRT first function that it starts is the user code main. So the CRT will call, actually let's put this out because it's not really part of the CRT. It's actually part of user code. So here the linker will tell the CRT to start a function, our CRT startup function, startup code, which will in turn call into main. Of course, the user code will talk a lot to the CRT functions by calling them. The CRT will also detect, if it's a debug mode, will detect issues in user code and so on. So the user code and the CRT interact a lot. The CRT functions also talk a lot to the Win32 APIs. For example, if you want to display something on screen, you have to use a Win32 API. If you want to open a file internally, for example, just examples, we use create file to open a file. We use write console to write something to the console using printf, for example. So all of these functions are in the Win32 API. So the CRT have a heavy dependency on the Win32 APIs. So that's really a rough summary of my work.
Excellent.
Yes.
Thank you.
Thank you. When people say the CRT, first of all, CRT stands for C Runtime, as most of you already know. The C Runtime or the CRT is, when people think of the CRT, they shall think of printf or sprintf or scanf or whatever, any of these functions. But the CRT is really a lot more than this. It's more than a standard library or implementation of the C Runtime standard library. It's also the layer that links between user code and the compiler. It sits in between the compiler and tells it what to do, and also the compiler tells it how to run the user code. For example, the C Runtime takes care of the main function. Whenever user application define main, it will actually call code in the CRT that in turn will run main. It will pass to main all those parameters such as the arguments, the command line arguments, as well as number of these arguments, and in some cases environment variable as well. Not only this, it will actually also call winmain. If we're running a Windows application, the C Runtime will pass some information to winmain as well. So that's one part of the CRT, which is really standing between the compiler and the user application. Another part is it handles, or it contains all these functions that allow the user easy handling of a little bit complicated stuff, such as all that mem copy, mem move things, which allows the user to easily work with memory, and all those useful string functions such as sprintf and all these store copy, store len, and all those useful functions. Well, it has hundreds of APIs, hundreds of functions really. So that's another part. Many of these functions are really a layer between user code and Win32 APIs. It makes our lives as programmers a lot easier because it hides the complexities of calling Win32 APIs. For example, a begin thread function will hide the complexities of create thread. Printf will hide the complexity of having to go and write something to the console directory and having to actually format it yourself and then send it to write console or some other function like this. So it's really a layer hiding abstracting the OS functionality. It handles a lot of other things as well. So some of these things, for example, it takes care of the internals of some of the exception handling. Together with the compiler, it makes sure that exception handling works smoothly. So when you say try catch, it actually takes care of that, a lot of that stuff. It allows you to work with GS cookies. Most of the GS cookie, and I'll explain in a moment what GS cookie is about, it allows handling buffer overruns. It actually, whenever you get a buffer overrun, that's the CRT work in progress. It tells you, oh, I found a buffer overrun here. Okay, I'll stop now. I'll tell you about it.
Okay.
Yeah, there are CRT is a lot. It's very useful when debugging applications. It has lots of functions and macros that will allow you to work with the heap, for example. So we have the debug heap, which is part of the CRT, which allow you to find if you have any memory leaks. It allows you to find if there's any memory corruption. We have all those asserts. Whenever you have an application and suddenly you find, oh, pop up an assert, that assert is really coming from the CRT. So when I say the C runtime, also it says C as the first letter of it, but the C runtime is also a major component of the C++ runtime.
Okay.
So it's really standing in between the compiler and the C++ runtime as far as exception handling is concerned. In C, you can't really, I mean, in pure C code, you can't really handle exceptions, right? Okay. Except if you use SEH, for example, sure, or some other. But you can't use the C++ try catch unless you're compiling as a C++ application. So but the C runtime takes care of internal stuff that's as far as exception handling is concerned. For example, when you get an exception, you get a full stack of what happened. Okay, so we call this stack unwinding. The C runtime takes care of stack unwinding. It actually has all the code that will allow you to unwind the stack and say, oh, printf is called by my application, which is internally called by C runtime. So that unwinding is actually part of the C runtime.
I see.
In addition, some components of the exception handling mechanism are implemented as part of the C runtime library, such as throw, for example, or terminate. So, for example, whenever you want to override the terminate function, and terminate function is actually part of the C++ standard, the terminate function is called whenever there is an unhandled exception. That whenever you don't catch an exception, we call the C runtime finally calls an exception handler, which is we call terminate, and depending whether if you have a registered terminate function, then this one will be called by the C runtime code. Otherwise, the C runtime actually just terminates the application. It's called terminate process, and the application is done. So while really you can't write, while really the C, while in C code you can't really handle exceptions the same way you handle them in the C++ application, C runtime or the CRT DLL actually takes care of the internal exception handling mechanism. So I'd like to talk a little bit, just for a few seconds, about how to build the C runtime application. So the C runtime application is actually compiled, is actually linked. You never actually link to the C runtime library in your application explicitly. Most what users do is actually build through Visual Studio, or simply use one of these arguments to your compiler. So use MD, or MD with D, or MT, or MT with D. The difference between these is quite simple. Both of these first two, MD, will allow you to link to the C runtime DLL, which we call MSVCR, currently for version 10 of Visual Studio 100.dll. Okay, so both of these. Sorry, only the first one will allow you to actually link to MSVCR 100. The second one will allow you to link to a very similar library, but MSVCR 100 D.dll. So this is D stands for debug. So both MD and MDD just means that you are linking dynamically to the C runtime DLL, meaning most of the code of the C runtime will stay in the DLL and it will never get linked statically into your code. And this is nice because whenever we fix something in each of these, we distribute it to all users that have these components installed on their application. So if we get any security issues or performance bugs, we just distribute other ones, and this will be available in user machines. So really, if you link dynamically, this is your best option here because you are guaranteed that all our fixes will go to the user. And not only this, you would not have to distribute any of your components again. Okay. However, MT and MTD, these are really for statically linking to the C runtime cmt.lib. You static link to the C runtime static libraries, meaning when you link to these, you don't really have to distribute anything else with your application. All what you need to do is just link to these, and then the right parts, if you use printf, then printf will be static linked in your exe. The right parts of the C runtime will actually go inside your exe. So all what you need to distribute is your exe or your DLL or your component that links with these. So each of those have their advantages. Okay, one thing to make sure that I've mentioned is when actually you link to these, you link through a library called msvcrt.lib, which actually point to msvcr100, or msvcrt.lib, which this is an import lib both for msvc100 and msvcr100d.dll.
Sure.
So
Cool.
that's how you link.
Excellent. So let's talk about static initializers. And
Okay,
why they're important, how they work.
Well, yes. A lot of people don't know how what are static initializers. What are they? They just here's the name static initializers. Oh, my static initializer has failed. My static initializer has failed during destruction, and so. So what are static initializers? Well, it's actually quite simple. So just erasing all of this. Okay. Sorry about
I got it. Oh,
Yeah.
Okay.
So, simply speaking, whenever you have a static or global variable in your application, for example, here you have your main, and here you have a struct. So you define your struct somehow. Struct, for example, let's call it x type, and then you say x type x. This here needs to be initialized, and it has to be initialized before any of your other components are initialized in your application. So what here is where the CRT role comes. The CRT looks at each of these, actually the compiler of course passes them each of these, and it creates what we call static initializer. We have a special section in the application where we actually embed these static initializers, and the CRT takes care of calling each of these initializers. It actually goes through them one by one. For example, if you have more than one here, it will go through them one by one, and it will call the constructor or the code, if it's a class, of course, the constructor or the code that will construct each of them. Of course, in this case, actually, sometimes, of course, if you don't use it, the optimizer will take it out. So if you say here x.y or x equals some value, for example, this means that the code is being used in your main. And even before main is called, we have to make sure that x is initialized. So that's why the CRT is very important. Not only the CRT initializes those, and by the way, that's why they call static initializers, because we really embed functions to initialize each of these in the application code. So hence static initializers. We also have code to call the destructors of each before the application terminates. We need to make sure of this. So the CRT has a function called doExit. Okay, some of you know about exit and or doExit or such or @exit. Sorry, it's actually called internally we call it @exit. So @exit. So what we do is actually we add a number of we call it @exit with the static, now we can call it static destructors really, because they destroy these, and we register each of these in the right order, in the reverse order of how they're created. So we make sure they actually are destroyed also in the right order just before the application ends. Yeah, I think many of you also knows about @exit. You can really register any of your functions through @exit, so it will be called whenever your application terminates.
Okay. Excellent. Well, let's look at some code, man.
Here's my very basic C function. Well, whenever you call tmain, you're really calling it from one of the C runtime functions, printf. So I will just dig a little bit into each. So I've talked earlier about the C runtime calling main. So here is how your application look like. I'm sorry, it's a little bit small. I can make it any larger here, but okay, let's actually zoom in. So this is your stack. Okay, so as you see, whenever you call application, you're actually calling into some kernel and Win32 APIs. So NDL calling kernel32, and finally it will actually call main. So who calls main? It's actually an internal entry point defined by the linker. If you don't provide any entry point into your application, entry point means where will your application start running? Okay, the functions that your application calls. So the default entry point in any console application, this is a console application, is wmain startup, or actually which will eventually call main. Okay, unless you define another entry point, and most users will not do this unless you have specific needs. And for Windows applications, it's winmain. So for console application, it's main or wmain if you're running a wildcard version, and for Win applications, winmain. So actually, you will have, so the source code for many, or actually most of the C runtime functions is available whenever you install Visual Studio. The C runtime source code is actually available for you. Okay, you cannot, so you'll be able to understand what's happening. For example, we talked about security cookies. So this is the CRT startup function, and this is actually where it calls the security cookie. At first, C runtime takes care of initializing cookie as well as checking the cookie later on. Actually, here's a call for this is winmain. We use a lot of if-defing because we like our code to be consistent among different platforms. Okay, I just so this is main, actually, and finally main calls another CRT function, and at the end it actually calls your main. This is a Unicode application. It's compiled with Unicode defined, so it will actually call into your main, which is your application. So this is your call stack.
Nice.
Yeah, another function which is printf. All the source code is also available for you. It will show you what we do. We parse the parameters here. We actually go through all the functions, all the arguments you give us as VList and vargs, okay, variable args, and internally I would not actually try to dig in deeper because it gets a little bit more complicated, a lot more complicated. Internally, we have a lot of functions that are shared among different. For example, if you call printf and wprintf and cprintf, internally all of these functions are going to call into the same code. Okay. However, another area I wanted to show you the code for is how we actually check the parameters. So let's stop this application. Okay, so some of the functions we have are secure functions. I want to show you a little bit about this because what do we do? So if you memcopy from some size, you only have 3 parameters here for memcopy. One of them is destination, source, and size. And I will show you a little bit. So memcopy just uses 3. We have another more secure version, for example, of memcopy is memcopy_s. What memcopy_s is, it makes sure that you add another parameter that will allow you to validate the size from where you're coming, from where you're copying to where you are copying to. For example, if what you're copying is larger than what you're copying to, then there is a problem. Of course, you cannot do this because you'll get a buffer overrun. So it will stop you from doing this actually even before you have run your code. Okay, so we'll use some of the CRT. So memcopy, we want to copy from some so void pointer from source, and malloc is another CRT function. Okay. You can just use this. So what you want to copy from is, you want to copy from into destination really. So here, and we know that the size is 100, and you're copying from source, also another 100. Okay. So if you run this application, it will actually run fine. However, if, for example, the user made a mistake, for example, what you're copying into destination, you're copying into 100 byte destination buffer, you just added a 0 here. So what will happen here, let's just run it and see what will happen. You'll get this nice assertion flag that will say size in bytes is greater than count. So all of these were part of the enhancements that were added to the CRT earlier a number of years ago to make sure that your application is safer, more secure. _S stands for secure or safe, I'm not really sure, but it's something. Underlying, you can actually go and debug your code, retry here. It will actually say, we have a breakpoint here. This is the security enhancements that have been added to the CRT. Okay, so you break here and it tells you what happened. So, oh, I was validating. It's a little bit hard to find out from this code, but basically you know that your size in byte is greater than the count. So here you have some problem. It will tell you. And of course, if you look at your stack here, it will tell you that, oh, I was just calling memcopy here, and it told me something is wrong. Of course, the validation, here we have numbers, but mostly in your code you will have more than integer constants. Here you will be using dynamic runtime.
Such a nice guy, you know?
Yes, he is. Mahmoud's amazing.
So feel free, please, to send us your feedback, you know, about the interview you just watched, about the CRT, etc. Same applies, you know, for the demos I was showing about the next version of the IDE.
Yes.
So why don't you tell me a little about you? You know, I was trying to look for you last week and I couldn't find you.
I was in the mountains in Canada, man, in the Canadian Rockies.
Wow. Yeah. What were you doing there?
Well, I mean, in some sense, you know, I certainly wasn't hiking.
Okay.
But I was at C++ and Beyond, which
really?
is just a killer conference.
Yes,
It's a small little affair.
It's probably from the, you know, standpoint of the pure C++,
Absolutely.
It's probably the most important conference around the world.
Absolutely, man. But I will tell you this, the two main compilers there were ours and GCC.
Okay.
Now I am noticing that Clang is starting to be, you know, getting actually pretty damn good.
Okay, getting some traction.
Oh, absolutely.
Wow.
So, or Clang, if you will.
Sure.
So, but yeah, I mean, it was amazing, and I could sit here and gush on about it and talk a lot about it, and I will talk a little bit about it, but I prefer to have you hear it from these brilliant folks.
Let's watch it.
Presenters are great. They're just, you know, incredibly smart, and they present it well.
In my industry, because I've done lots of embedded coding, and I work very close to IC designers. In that industry, C++ is just blossoming, I would say. It's just coming into the light, so to speak. It's its first renaissance, if you will.
My most desirable feature is probably, memory model aside, because I think that's probably the most important thing, is using the template aliasing.
Yes.
And so it's very sad that no one implements that yet.
I think it's been excellent. I mean, well, the presenters especially, it's three of the most professional, humble guys that I've seen. They're very, I suppose the best term would be intellectually honest with everything, in that they're really smart guys. They know what they're talking about, but at the same time they'll say, you know, there's limits to them as people and the concepts that they're doing, and I think that's a great thing for programmers to hear, because, as you know, nothing's free. There's always going to be a compromise, and it's great that they're honest enough about that to educate everyone.
It's frustrating that lambdas don't have types. You know, they have this kind of anonymous type, but you can't look inside it, but that's slightly frustrating. So don't get me wrong, I'm not saying I'll never use auto. Actually, I've got code that I already use auto. And my problem is that we'll abuse it. You know, people will just stick it everywhere. And when people say, I'm just going to stick all over my code, and you know, I don't know how useful that would actually be.
And one of the things that I've liked about the conference is it shows really how deep the pool goes. In that, because I'm new and I'm still picking things up, I find that these guys are a decade ahead of me, at least, in terms of what they know and the features they're able to extract. But I like knowing that because that means I'm not at the end. I'm not running into barriers, I'm not hitting the limits. I'm just at the beginning, and there's way more potential. And the best part about that is that these guys are thinking about how to push the limits before I even get there. And I think that's one of the great things about C++ and the standards that go with it.
And in my industry, it never left.
Right
I mean, it's the only language we had.
Performance is a big issue.
I have to say that during kind of I would say the dark days, when Microsoft wasn't telling the story about C++, I was worried that I would have to go to strictly GCC. For me, you know, hearing that more talk about native code is a good thing.
Oh, for sure. I mean, the C++ renaissance in Microsoft was real, man.
It is my first time here, yeah.
What do you think?
Yeah, it's great. Yeah, it's been very interesting, and I somehow would have liked to have been a little bit more advanced.
More advanced?
Yeah, and some of the detailed discussions, you know. But I suppose that's just my, you know, my experience.
I mean, what did Andre say again today?
Yeah, so Andre's talk was great. Yeah, no, actually, his talk. That, you know, the policy stuff is getting, you know, that's the limits of template programming. Certainly the limits on my mind. So I'm quite happy with that. But,
yeah, very adequate.
But I think it's not really that. I think it's pretty just a personal choice. You know,
sure.
Interest. You know, what I prefer. Yeah.
Excellent.
But overall, it's been great.
So most of the code I write, because I build a lot of the libraries we use, is template-based. So for me, templates is all good. Anything they add to templates, I'll take advantage of.
Man, it was so fun to meet those guys. I mean, we had some serious geek out sessions, brothers.
Thank you for showing that.
Absolutely. And that's only part and little segments that were made.
Okay.
I do have longer interviews of each of those that I will post on Channel 9.
Okay.
And also, to mention a little bit more about C++ and beyond, I sat down with Herb and Andre and Scott. Of course, these are the Herb Sutter, Andre Alexandrescu, Scott Myers, the C++ titans.
Is that recorded or just?
It's recorded.
Wow.
And in fact, it's on Channel 9 right now. So after you're done watching Going Native, click on the link, probably right around there somewhere.
That's great.
It's good stuff, man. Oh, it's so great to talk to them. And I highly recommend that conference. Go to C++ and beyond if and when they do another one. In fact, Herb, Scott, and Andre, please do another one focused specifically on some of the, as Scott mentions in the interview that we did, that focus a little bit more on the boundaries of C++ 11.
Okay.
Pushing it out. Now, Andre did some crazy template stuff, and Scott did some, you know, mind-bending memory model stuff.
Okay.
And Herb does his usual, you know, Herb really is a hardware kind of guy.
Yes.
And so his GPU stuff was just rock and roll.
Great.
And it's all just mind-bending. So thank you guys, and enjoy that content.
Great.
Rock and roll, man.
Okay.
So hey, where are we right now? Are we in the destructor?
We need to destruct the program.
All right.
Absolutely.
Well,
okay.
1, 2,
3. Destruct.
Destruct.